Hey, welcome to The Explainer. Today, we are going to tackle one of the core concepts in system design, sharding. We'll get into what it is, why it's tricky, and most importantly, how you can absolutely nail the conversation about it in your next big interview. All right, let's paint a picture. Imagine your app just blew up. It's a global hit. But your database, it's angry. It's really angry. You're hitting storage limits, writes are timing out, and backups feel like they take an eternity. What do you do? Well, your first thought is probably, let's just get a bigger machine. That's called vertical scaling. And you know what? It works for a bit, but you'll always hit a hard limit. There's only so big a machine you can buy. That's when we have to think differently. We have to scale out, not just up. And that brings us to the core idea of sharding. Instead of one ginormous, overworked database, you literally break your data into smaller chunks, or shards, and spread them out across a bunch of different machines. And here's the magic of it. Each shard is its own little standalone database. It has its own CPU, its own memory, everything. So when you need more power, you don't have to do some massive, risky upgrade. You just add more shards. It's that simple. This is how you build systems that can handle pretty much anything the world throws at them. Okay, so sharding sounds like the perfect solution, right? Well, not so fast. It solves that huge scaling problem, but it creates a whole new set of complex questions. To do this right, we've got to make two really critical decisions right from the get-go. First up is the shard key. Think of this as the rule that tells us how to group our data. A really common one is something like user ID. And second, we need a distribution strategy. This is the logic that decides which physical machine each of those groups actually lives on. So, and I can't stress this enough, choosing that shard key is everything. A good key has to have a ton of unique values, what we call high cardinality. It needs to spread the data out evenly so you don't get hotspots. And maybe most importantly, it has to align with how you actually query your data to keep things fast. Let's make this real. For an app like Instagram or TikTok, user ID is a beautiful shard key. But what if you chose something like is premium? You know, a simple true-false field. That would be an absolute disaster. Why? Because you're instantly limited to just two shards. One for your paying users and one for everybody else. That doesn't scale at all. All right, so we've got our key. Now how do we actually map that key to a machine? You'll see a few strategies here, but honestly, in an interview, you want to talk about hash-based sharding. That's the industry standard. Specifically, you should mention consistent hashing. It's a clever algorithm that uses a hash function to assign shards, but it does it in a way that when you add a new server, you don't have to reshuffle all your data. Only a tiny fraction moves. It's the go-to answer your interviewer is looking for. Okay, but sharding isn't a magic wand you can just wave at your scaling problems. You solve one big issue, but you create a few new, really tricky ones. And you can bet your interviewer is going to ask about these next. The first and probably the most famous problem is the hotspot. People love to call this the celebrity problem or the messy problem. You've done a great job spreading your millions of users across your shards. But one of those users happens to be Lionel Messi, and his profile gets 1 billion times more traffic than anyone else. And the result is this. You see that one shard, Messi's shard, is getting absolutely hammered. It's handling 90% of the load. Meanwhile, your other shards are basically just sitting around, bored. The whole system is completely out of balance. It's super inefficient. So how do we deal with this celebrity problem? Well, there are two classic patterns. One, you could use a compound shard key. So instead of just user ID, maybe you shard by user ID plus post ID. This breaks up the celebrity's data across more machines. Or, two, you can actually detect these high-traffic accounts and move them to their very own super powerful, dedicated celebrity shard. All right, challenge number 2, the dreaded cross-shard query. This is a huge headache. It's what happens when the answer to a single question is spread across multiple machines. Now your system has to go talk to all of them, which is slow and complicated. Look, if you're asking for something that aligns with your key, like get all of user 123's photos, that's lightning fast. It hits one shard, gets the data, done. But what if you ask, what are the top 10 most liked photos on the entire platform? Well, now you've got a problem. You have to ask every single shard, get their top photos, and then combine all those results. It's incredibly slow and expensive. So what do? Well, your first line of defense, always, is picking a great shard key that minimizes these kinds of queries. But you can't avoid them completely. So for those unavoidable global queries, a really common pattern is to pre-calculate the answers and stick them in a super fast cache like Redis. Some people might even duplicate certain data to keep related info together, though that comes with its own trade-offs. And that brings us to maybe the trickiest problem of all, maintaining consistency. Just think about a simple bank transfer. What happens if you need to subtract money from Bob's account, which lives on Shard 1, and add it to Alice's account over on Shard 3? And what if the second part fails? This is a really hard problem. Now, the old school textbook answer here is something called a two-phase commit, but it's known for being slow and locking up your system. A much more modern, practical solution is something called the saga pattern. The idea is you break the transaction into a series of smaller steps. Each step has a corresponding undo action, so if any part of the chain fails, the system just runs the undo actions in reverse to clean everything up. It ensures things are eventually consistent without grinding everything to a halt. Okay, you get the theory, you understand the trade-offs, so how do you package all of this knowledge into a killer answer when you're in that high-pressure system design interview? First thing, and listen, this is probably the most important tip I can give you, always start by justifying if you even need to shard. Do some quick back-of-the-envelope math. Modern databases are absolute beasts. Showing your interviewer that you've done the math and decided not to shard, well, that can be way more impressive than just jumping straight to it. But, okay, let's say the math checks out and you do need to shard. Here is the exact 4-step playbook you should follow. 1. Propose a shard key and justify why it fits the access patterns. 2. Choose your distribution strategy. Default to hash-based with consistent hashing. 3. Explicitly call out the trade-offs. Talk about hotspots and cross-shard queries. And 4. Talk about the future. Explain how you'll add more shards as you grow. Okay, let's assume we have 500 million users, and each user's data is about 5 kilobytes. That comes out to 2.5 terabytes. Then you deliver the killer line. A single large database instance can actually handle that for now, but we'll architect the system with a shard key in mind, so we're ready to shard once we project 10x growth. You see, the point here isn't to find some single perfect answer. There isn't one. The goal is to have a conversation and show your interviewer that you deeply understand the trade-offs. It's all about how you think through these complex engineering decisions. And that really is the key takeaway. Sharding is an incredibly powerful tool for scale, but it's never the end of the story. The real art of system design is this constant cycle. You solve one bottleneck, which just reveals the next one waiting for you down the road. The conversation and the engineering never really stops.